Edexcel Core Pure, Calculus 5, Integration Techniques. Substituting x equals sine u. Just to recap some of the things we've already seen. We've already seen that we can integrate 1 over the square root of 1 minus x squared as arc sine x plus c. Cos u can be written as the square root of 1 minus sine squared u. And the derivative of sine u with respect to u is of course cos u. The reason we're using x's and u there is just to remind you that if we talk about arc sine x equals u, then of course x equals the sine of u. This substitution of x equals sine u may be a useful way of approaching integrals which involve the square root of 1 minus x squared, as we will see in the next examples. So here we need to integrate this function with respect to x. The 1 minus x squared, particularly with that power a half, does suggest letting x equal sine u. dx by du is of course cos u, and dx can be substituted by cos u du. So this integral becomes the integral of 1 over 1 minus sine squared u to the power 3 over 2 times by cos u du. So it looks a bit awkward at the moment, but it will become much nicer. We've got a cos u in the numerator. 1 minus sine squared u, that inside that bracket is cos squared. So that denominator becomes cos squared u to the power 3 over 2 du. So it's already looking much better. Cos squared u to the power a half is cos u. And when we cube it, we get cos cubed u. So we end up with cos u over cos cubed u du. And if we cancel out the cos u, we get 1 over cos squared, which can be written as the integral of sec squared u with respect to u. So we've ended up by making a sensible substitution with something that is much easier to integrate. So if we now look at integrating sec squared u with respect to u, we know the integral of sec squared u with respect to u will be tan u, so that step's pretty straightforward. But what we need to do now is to get it back to a function of x. We know that x equals sine u, so we need to start working back towards a function of x. One approach is to write tan u as sine u over cos u plus c. I can substitute for sine u now. I know that sine u is x, but we need to know what cos u is. If sine u is x, then x squared is sine squared u, and 1 minus x squared is 1 minus sine squared, which is cos squared u. So cos u is the same as the root of 1 minus x squared. So now we're in a position to rewrite this answer, not in terms of u, but in terms of x. So sine u is x, and cos u is the square root of 1 minus x squared. So just picking out, there's quite a lot of detail, just picking out some of the important thoughts here. The 1 minus x squared to the power a half is a clue that x equals sine u is a good substitution. Once you've made that full substitution, make sure you simplify the denominator as much as you can. So we ended up simplifying it all the way down to cos squared u, which then can be written as the integral of sec squared u. Once you've got it, the answer in terms of u, then we had to get it back as a function of x, and we did that by using sine u is x, and we created a cos u is the square root of 1 minus x squared in order to make the substitution back. So in the second example, we're going to integrate, it's a definite integral, notice. That will be significant shortly. We're going to integrate the square root of 1 minus x squared with respect to x. Again, this square root of 1 minus x squared is an indication to let x equal sine u. So we get dx by du is of course cos u. dx will behave like a cos u du. Do not forget, because it's a definite integral, we need to change our limit. So we need to ask ourselves, when x is 0, what will u be? And when x is a half, what would u be? So when x is 0, we've got sine u is nothing, so u is nothing. And when x is a half, we get sine u is a half, so u is pi by 6. Make sure you're working in radians. So some people, to remind them to change the limit, like to put an x equals on the original limits. And that gives them a little visual reminder that these new limits are u equals pi by 6 and u equals 0. The square root, so it's not 1 minus x squared anymore, it's going to be 1 minus sine squared u, and dx is a cos u du. So the limits are 0 to pi by 6, and they are values of u, remember. 1 minus sine squared, we've seen many times, is cos squared. So this becomes the square root of cos squared u times cos u du, which is the integral from 0 to pi by 6. The square root of cos squared is of course cos, times the extra cos is cos squared u du. So we haven't finished the problem, but we've certainly ended up with an easier integration which we can have a go at now. So now we've got to the integral of cos squared u du from 0 to pi by 6. There's a neat way of dealing with cos squared u, and what we do is we think about double angle identity. So we've got cos 2u is 2 cos squared u minus 1. Therefore, cos squared u is a half of cos 2u plus 1. And it's the squared in this integral which is making it difficult. Therefore, if we rewrite this integral as the integral from 0 to pi by 6 of a half cos 2u plus 1, then it is an easier integral. We don't have the squared term to deal with. So this is integrated now as a half. Don't forget that you'll need to balance it up with a half. It's not just sine 2u. A half sine 2u plus u, and the limits are 0 to pi by 6. And now we can sub the limits in. So subbing in the top limit, we get half sine 2 lots of pi by 6 is pi by 3 plus pi by 6 minus a half, and subbing in the bottom limit, sine of nothing is nothing and u is nothing. So it's, you must make sure you put that bottom limit in, even though it's obviously going to be a 0. So now we have a quarter of sine pi by 3, which is root 3 over 2 plus pi by 12. So we have root 3 over 8 plus pi by 12 as the answer to the original integral. So the key steps were to spot the square root of 1 minus x squared as a clue that we can use x equals sine u. Don't forget to change your limits into limits of u, and the reason we made that substitution is in order to simplify this integral all the way down to cos squared u. It's the squaring of this trig function which is making it difficult, so that fairly familiar use of the double angle formula makes it much easier to integrate. So in summary, if we see integrals involving the square root of 1 minus x squared, then these can be transformed by this substitution into something which will be easier for us to integrate. The resulting integral may need a further technique. For example, you may need to use a double angle formulae to make it even easier to integrate. And don't forget, if it's a definite integral that you have been given, that the limits need to be changed as well into the new variable. So you make a full substitution throughout the integral, including the limits. In the next session, we're going to be looking at substituting using x equals tan u.